Now, in this video, we will going to take a problem on projections of solids. How to analyze this problem and solve this manually. A hexagonal pyramid, 25 mm sides of base and 50 mm axis length, rests on HP on one of its corners of the base, such that the two base edges containing the corner on which it rests make equal inclinations with HP. Draw the projections of the pyramid when the axis is inclined to HP at 40 degrees and VP at 30 degrees. So this is the problem. So first let us take the initial position as first on the horizontal position. We can see that two of the base edges containing the corner on which the on which the solid rests make equal inclination. That means you can see the point A and D. Both, if you draw a vertical projector here on these two, you can see the equal inclination. The inclination made by the line AF with respect to the vertical and the inclination made by AB with respect to the vertical will be equal. Similarly, the inclination made by the line DE and CD with respect to the vertical will be equal. So that is the meaning of that. Now, so since he wants the corner has to be on HP, so you make the initial position of the hexagon to be on the horizontal position such that the corner will be at the extreme points. So this is, and when you look from the top view, I can see the base of the pyramid which is 25 mm, and when you look from the front view, I can see the height of the pyramid which is 50 mm. So how to solve this problem by using manually? So first we are going to draw the XY line and you mark VP and HP. So then, since I want to draw the hexagon in the horizontal position by using the inscribed polygon in circle. So first I will going to draw a horizontal line. By using the compass, take any point on that horizontal line and take the radius as the side of the hexagon which is 25 mm, and take the radius of 25 and draw a thin circle first. Then which will going to pass the diameter in the horizontal direction between these two lines. So you mark this point as small e and you mark this point as small d. Then with A center, taking the same radius of 25, cut on the circumference of the circle on this side and also on this side. Similarly with D as center, take the same radius of 25, cut on the circumference of the circle on this side and also on this side, so that you will going to get 6 points. The circle should be thin, and then you mark these points. Mark this point as B, you mark this point as C, you mark this point as E, and you mark this point as F. And join AD with a dark line, CF with a dark line, and BE with a dark line. And you mark these 2 points with O and O1 in bracket. Then draw a vertical projector from A to the XY line, and similarly from B and E to the XY line, B and F to the XY line. From O you draw a vertical projector to the XY line and you take it to the front side. Similarly from C and E to the XY line and also from D to the XY line. As you look from the front view, I can see the height of the pyramid. The height of the pyramid is given as 50. The front view is seen in vertical plane. From this point, you measure a length of 50 and you mark this point. You mark this point as O dash and you mark this point as O1 dash in bracket. Because as you look from the top view, O is near to the observer, so it is visible, and O1 is away from the observer, it becomes invisible. Similarly, when you look from the front view, since O1 is on the base of the hexagon and this is covered by BC, therefore O1 dash will be in bracket. Now, as you look from the front view, A, B, C and D are near to the observer, so A dash, B dash, C dash and D dash are visible. E and F is away from the observer, therefore you keep E dash and F dash in bracket. Then, since we have joined between OA, OB, OC, OD, OE and OF in the front view, in the top view. Similarly, you join between O dash to A dash with a dark line because O dash is a visible point, A dash is a visible point. So visible to visible is visible, so you dot this. Similarly, O dash is a visible point, B dash is a visible point. visible to visible is visible. So O dash B dash you mark a dot point. Similarly, O dash C dash with a dot line and O dash D dash with a dot line. And since A to D, as you look from the front view, A dash B dash is visible, B dash C dash is visible, and C dash D dash is visible. Therefore, you draw a dark line between A dash and D dash. Now, this is how you will be able to write the front and top view of the initial position of a hexagonal pyramid having a base of 25 mm and the height as 50 mm. Now, as you look from the top view, A, B, C, D, E, F are totally visible. So, A, B, C, D, E, F is without a bracket. Now, A dash, B dash, C dash, F, D dash, E dash and F dash all are parallel to HP. Therefore, you are getting the true length in HP. HP is in the top view. So, therefore, AB is equal to BC is equal to CD is equal to DE is equal to EF is equal to FA, where the side of the hexagon which will be 25. Now, then he says it is resting on one of the corners on HP. The two of the corners, the two of the base edges containing the corner is make equal inclinations with HP. You can see that when it is rotated, you can see both DE and DC will make equal inclination with HP. So here, so how to write this? So we have a corner position here and also the corner position is here. If you keep on, you can keep it on any one of the corners. If you want to keep it on A dash, then you have to rotate the solid in the counterclockwise direction. And if you want to keep it on D dash, then you have to rotate the solid in the clockwise direction. In this case, what I have done is I have kept D dash on XY line. So that means the right end of the corner is kept on XY line, that is on HP. So I am rotating in a clockwise direction. As we see, the axis is inclined to HP. Since the axis is here, if you rotate with respect to D, then axis will go to the above. So how to rotate? I need to rotate the base. When you rotate the base by certain angle, the axis, you should make an angle of 40 degrees. How to do that? This, when you rotate this becomes an equilateral triangle. You can see here, this is the equilateral triangle. Here to here and here. So if this angle is 40 and this angle is 90, what should be this angle? 180 minus of 40 plus 90. So that means that is 40 plus 90 becomes 130. 180 minus 130 will be equal to 50 degrees. That means if I rotate the base by an angle of 50 degree, then the axis will automatically be inclined at 40 degrees to HP. So by using the protractor with D dash center with respect to the XY line, you measure 50 degrees from the clockwise direction and then you mark that angle as 50. Then join D dash to that point and you extend it. Then by using the compass, you measure the distance from D dash to A dash with D dash as center, cut an arc on that 50 degree line. So you mark this point as A dash. Then you measure the distance from D dash to O dash and by using the compass with D dash as center, draw an arc. Similarly with A dash as center, you measure the radius of A dash O dash from the first position front view and transfer it from A dash and to cut on the previously drawn arc and you mark that point as O dash. Then you measure the distance from D dash to B dash with D dash as center, cut an arc on this 50 degree line. Similarly with A dash as center, take the radius of A dash C dash. From A dash you cut an arc on this line and then you measure the distance from D dash to O1 dash. From D dash you mark it on this 50 degree line and you mark this point as B dash, then you mark this point as C dash, then E dash in bracket, then F dash in bracket, then O1 dash in bracket. Then join O dash to A dash, O dash to B dash, O dash to C dash and O dash to D dash with a dot line and join between D dash to A dash with a dot line. Then you join O dash and O1 dash with the axis line, that is big dash and small dash, big dash and small dash. So once you do that, now I need to write, so this is how I will going to rotate the axis by an angle of 40 degree. such that one of the base edges is resting on HP, such that the two of the base edges containing the corner on HP makes equal inclinations. That is, DE and DC are the two of the base edges which are making equal inclination with respect to HP. Now, I want to draw the top view. Draw a vertical projector from A dash and then O1 dash, then D dash and then O dash to the top view. And then draw a horizontal projector from A, O, D and O1 to the vertical projector drawn from the second position front view. And on A dash vertical projector, this A will be intersecting, and then from O1 dash vertical projector, it will going to be intersecting here, which is O1, and from D dash vertical projector, which is intersecting at this point D, and from O dash vertical projector, which is intersecting at this point. So you mark this point as A, and then you mark this point as O1 in bracket, you mark this point as D, and you mark this point as O. Don't mark it as bracket D, you just mark it as D. Now, draw a vertical projector from both B dash and F dash and also C dash and A dash to the top view, and draw a horizontal projector from FE and also onto the BC to the second position top view, and this F dash vertical projector will going to intersect at F and at B also, and C dash vertical projector at C and also on E. Then you mark these points A, B, C, D, E, F and O and O1. Now what I need to do, I need to write then join A to B, B to C, C to D, D to E, E to F with and F to A with thin lines. And similarly join between OA, OB, OC, OD is already joined, OE and OF with thin lines. Don't dark them. Now you apply the condition of visibility. How to do that? All the exterior edges of the boundaries of the solids are visible. So which are the exterior edges of the boundaries of the solid? AB, BC, CO, EO, FE and AF. These edges will going to form the exterior edges of the boundaries of the solids which are visible. Therefore, you dark them. So, the whatever I have shown in the blue color is the one which is to be darker. Then, the edge which is nearer to the observer is visible. Which is the edge which is nearer to the observer? Where is the observer? Observer is looking from the top view. Since O dash, A dash is the edge which is the slant edge which is nearer to the observer, so it becomes visible. So you can see O to A will going to be a dark line. Then the wedge which is on XY line in the front view is always invisible in the top view, which is that D. So you keep the D in bracket. Once you do that, D dash to C, D to C. D is a invisible point, C is a visible point. So visible to invisible is invisible, so you make a dotted line. Then E to D, visible to invisible is invisible, so you make it as a dotted line. Then the two invisible edges can never cross each other. If this edge becomes invisible, then FO is crossing the invisible edge of DE. Therefore, FO has to be visible because two invisible edges can never cross each other. Apply that rule. Similarly, BO is the edge which is crossing the invisible edge CD. Therefore, BO will become visible. Since some portion of ABCDE, that is CD and DE is invisible, therefore O1 will be in bracket. So this is how you will be able to write the visible and invisible in the second position top view. Then the axis is inclined to VP at 30 degrees. So what I need to do, So the inclination what he has given is the true inclination. As we see the axis which is inclined to HP at 40 degrees, once the axis becomes inclined to HP at 40 degrees, so in HP that axis will going to become apparent length. But the inclination what he has given is the true inclination. But from the projections of lines on the true inclination line, I must get only the true length. So I want to rewrite the second position top view. I cannot write this second position top view on this 30 degree line, because this 30 degree line what we have is the true inclination line, and the axis what we have is the apparent length. Since the axis what we have is the apparent length here, therefore I need to find out the apparent inclination here. So to do that, first you take any point and draw a horizontal line. By using the compass, you mark that point as O, and with reference to the horizontal, you measure an angle of 30 degrees and draw an inclined line. So this is the true inclination line. Since on the true inclination line, I will go to get the true length, as the axis is parallel to VP, so you are getting the true length in VP. So you measure the distance from O dash to O1 dash, which will going to be the height of the pyramid, which is 50 mm. By using the compass, you measure a distance of 50 with O as center, cut an arc on this 30 degree line. Then you draw a horizontal line, which will going to be the locus line. Then you measure the distance from O to O1 of the second position top view with the same point O as the center, cut an arc on this locus line. Then you mark this as O1 in bracket. Once you do that, then join between O to O1 and extend it. Then you measure the distance from O to A with O as center, cut an arc on that beta inclination line. You mark that point as A. On beta inclination line, you construct this sketch. Similarly, you measure the distance from O to D with O as center, cut an arc on that beta inclination line. You mark that point as D in bracket. Similarly, you measure the distance from O to this point. From O, you cut an arc on this beta inclination line. So, since this line is perpendicular to OA, then from this point, with respect to OA, you measure an angle of 90 degrees with respect to OA and draw a perpendicular line. Similarly, you measure the distance from this point to B and also from this point to F. Both are equal. Then with this as center, cut an arc on this perpendicular line on this side and also on this side. You mark this point as B and you mark this point as F. Similarly, you measure the distance from O to this point by using the compass with O as center, cut an arc on this beta inclination line. Then, with respect to OA, you measure an angle of 90 degrees by using the protractor. Then you draw a perpendicular to OA. Similarly, you measure the distance from this point to B and also from this point to F. From this point to C and also from this point to E. So transfer it from this point to C and also from this point to E. You mark this point as C and E. As we are rotating this, so that A will be here, B, C, D, E, F, and then this is O and O1. So rewrite the same sketch here, including the views. We need not have to change anything there. So now this is how we will be able to reconstruct the third position top view. Now I need to write the front view for this. How to draw that? Draw a vertical projector from the third position top view of O to the front view and draw a horizontal projector from O dash. Both these two lines will go into intersect at this point. You mark this point as O dash and draw a horizontal projector from A dash and draw a vertical projector from A. Both these two lines will go into intersect at this point. You mark that point as A dash and draw a horizontal projector from B dash and F dash to the third position front view and draw a vertical projector from B and also from F to the third position front view, or mark these points as B dash and F dash. Similarly, you draw a vertical projector from O1 and draw a horizontal projector from O1 dash. Both these two lines will go into intersect at this point. You mark that point as O1 dash. Similarly, and draw a vertical projector from C and also from E to the third position front view and draw a horizontal projector from second position front view, that is C dash and E dash. Both these two lines will going to intersect at this point and also at this point. You mark that point as C dash and E dash. And similarly, draw a vertical projector from D to the XY line and you mark that point as D dash. Then join O dash, then join A dash to B dash to C dash to D dash, E dash to F dash to E dash and F dash to A dash. Once you do that, then join between O dash to A dash, O dash to B dash, O dash to C dash, O dash to D dash, O dash to E dash and O dash to F dash with thin lines, and join between O dash and O1 dash with the axis line with big dash and small dash. Now once you do that, so this you are going to get on all these joints has to be done by using the thin lines. Now we have to apply the condition of visibility. What is the condition of the visibility? First one is all the exterior edges of the boundaries of the solids are visible. Join between O dash to A dash to B dash to C dash to D dash to E dash to O dash with a dark line which will going to form the exterior edges of the boundaries of the solid. Then once you do that, the surface near to the observer is visible. That means the entire base of the hexagon is totally visible. So then join between E dash to F dash and F dash to A dash with a dark line. Then from a point, if two edges are visible, automatically third edge is also becomes visible. So apply that rule now. So in that case, since from F dash to A dash and F dash to E dash, these two edges are visible. Therefore, F dash to O dash is also becomes visible. Then, two visible edges can never cross each other. So that means you have F dash to E dash is visible and F dash to A dash becomes visible. Therefore, B dash to O dash is crossing the visible edge of A dash F dash. Therefore, apply this rule. So O dash B dash will becomes invisible. Similarly, E dash F dash is visible. So O dash C dash is crossing the visible edge of F dash A dash. Since applying the same rule here, so O dash C dash will becomes invisible. And similarly, O dash D dash is also becomes invisible. Then what happens to the O1 dash? As the entire base becomes visible, therefore O1 dash is also visible. Join O dash to O1 dash with big dash and small dash line, which is an axis line. So this is how you will be able to analyze and solve the problem by using manual sketchbook. How do I know that my drawing is right? Even in the final position, you can see that the corner is resting on HP. Since the axis is inclined to VP, which the axis is inclined to HP is 40, the same axis is being inclined to VP at 30 degrees. So I need to find out the beta inclination. Hence we have found out this beta inclination, and the corner is resting on HP, and this is the base of hexagonal pyramid of 25 mm sides and the height is 50 mm. Since we have incorporated all the conditions which was given in the problem, and hence our problem is right. Thank you.